All right. Good afternoon, Calc BC. It's Friday, May 8th. We've got our AP exam on Tuesday at 11 a.m. The AP Central has given out this Google Drive of 5 for 5s, which are they're hopefully going to give us 5 mock exams here. And I'm assuming these are 15-minute ones because they're one pagers. And so I'm putting the timer on for 15 minutes as if it's going to be like question two. Question one is 25 minutes, of course. And you don't know how many sections there are until you get it. So I'm going to set the timer. I have not seen these problems. I'm going through them my first time. I am getting better, though, I feel like, at the timing. We'll see how we're doing. I've done most of them in the morning. Now it's the afternoon. So try to, do um, your practices in similar timing to the actual test. So ours is more in the morning. So hopefully you're doing a lot of practicing in the morning. But I did say I'd get these out to you by the weekend. So I wanted to get this one in. And let's see how we do. I haven't seen the problems. I'm going to treat it like it's a test so that when the test comes, I'm more familiar and comfortable with the layout and less stressed out in that regard. Okay, let's take a deep breath, and the timer is about to be set. Here we go. All right, I'll be given the test and the timer's running. So now I count how many sections I have. 2, 3, 4. There's 5 sections. I have 5 pages already set up, APID and your initials. So we got BC1, BC2, BC3. And on the test, it's going to be A, B, C, D, E, F, and so on. But just to practice and show that you do have the time to do this, and it does kind of save it when you're going from one problem to the next to not have to label it when you start it. Just go and start it. Here we go. BC1, let's look at it. F prime graph portion shown. Derivative of the twice differentiable function f. Area is labeled. F of 1. And this is, I'm just showing you this PDF because I wanted to be able to put it under the doc-cam, but you shouldn't be printing them out. You should be using the screen. And so you got to document onto your paper what's important so you don't have to keep looking up and looking at that darn timer. BC1, find all values of x in the open interval for which, so x equals what when f has a horizontal tangent line? That's when f prime equals 0 because it's twice differentiable, so it's not going to be undefined. And plus, it's a tangent line. Determine whether f has a relative minimum or maximum or neither. Okay, so f has horizontal tangent line when f prime of x equals 0, and that's when x equals -3, 1, 6, and 8. You guys, you got to be able to have no distractions during this time. I had to step away. I don't think I'm going to be able to finish now, but let's just see how I do with that distraction. Okay, -3 is an endpoint. That's weird. So I don't know if the derivative is changing signs or not. So neither at x equal -3 and 8 because don't know behavior for x values less than -3 and for x values greater than 8. And so I'm just going to leave it. Then x equals 1 is a max because f prime changes from positive to negative, and x equal 6 is a minimum because f prime changes from negative to positive. I think I'm good. Okay, justify, I think I did. Number 2, find the minimum value of f. Minimum value, that's a y value of f on justify. The minimum value, so actually we can take, so minimum, that's an absolute minimum, absolute min at possibly at endpoints, x equal -3 and 8, or at critical points, which is x equal 1 and 6. And that's when f prime equals 0. And so we can make a table, and we're looking at actual outputs of the function. And, well, that's not going to be easy. But we can do it, I think, because we know an initial condition, we can do area under the curve to give us the change in f, fundamental theorem. So we've got a -3, 1, 6, 8. Okay, so the integral of f prime of x from -3 to 1 is going to equal f of 1 minus f of -3, right? Fundamental theorem. It's the antiderivative evaluated at the endpoints. So the area under the curve from -1 to 3, -3 to 1 is 10. Equals f of 1, which is -2, minus f of -3. I mean, once you see me do this, you're going to realize that if the fundamental theorem is so nice. So then add 2, you get 12, equal negative f of -3. So -12 equal f of -3. Okay. F of 1, hey, they gave us that. It's -2. Okay. And then 6, x equals 6. So the integral from 1 to 6 of f prime of x is going to equal f of 6 minus f of 1. You see how I'm always using f of 1 because I know f of 1 and I also know the area under the curve. From 1 to 6, the area under the curve is -14 because integral is the assigned area. F of 6 I don't know, minus f of 1, which is -2. So that's a +2. So f of 6, add 2. No, that's a +2, so you have to subtract 2. So -16 equals f of 6. Okay, and then 8. Well, I know 8 is going to be not as small because of the positive area, but let's just do it just to show our work. 1 to 8 of f prime equals f of 8 minus f of 1. So the area from 1 to 8 is the signed area, so it's -14 plus 6 is -8. -8 equals f of 8 minus a -2, which is +2, so you got -10. All right, so -10. So there you go. Min at -16 when x equals 6. BC3. H of x equals e to the g of x divided by 3 of x. No, just 3x. Okay, we want h prime of 6. Well, I need h prime of x. Okay, well, that's a quotient, so I'll do quotient rule. Low, 3x, d high, which is e to the g of x times g prime of x, chain rule, right? Minus high, e to the g of x times d low, which is 3, and then square the bottom. You know what? I'm just going to square the bottom and simplify it because it's easier than writing 3x with 2 parentheses. Moving on. I need to plug in 6. H prime of 6 now is equal to 3 times 6, e to the g of 6 times g prime of 6 minus e to the g of 6 times 3 all over 9 times 6 squared. And I'm not going to simplify that, but I do need to evaluate e to the g of x here and g prime. So this is now, you know what, I'm going to write 18, whatever. E to the g of 6, g of 6 is 0, is either 0. I don't have to simplify that. G prime of 6 is 1 minus e to the g of 6, which is, again, 0 times 3 all over 9 times 6 squared. Okay, moving on. BC4. Particle moves along a straight path. Find the total distance traveled. Total distance traveled. That's arc length, because a straight line total distance traveled, it's going to be v of t is f prime of t. Good. So I know distance traveled is equal to the integral of speed. And distance traveled then is going to equal the integral of the absolute value of the velocity, because velocity is a signed area. So that's up and down. You could run a mile around a track, but if you take the integral velocity, you might get a 0 because of the positive and negative nature of your velocity vector going back and forth. So that means in our graph, we have to reflect it over the x-axis. Has to be positive. Okay, so distance traveled from 1 to 8. So it's going to be 1 to 8 dt. So that's going to equal the signed area under the curve from 1 to 8. So that's going to be 10 plus 14 plus 6. I think that's it. BC5. The integral from 1 to 9 of x times g double prime of x dx. Okay, that's classic u substitute integration by parts. Lucky 7. You pick a u, you pick a dv. U has to be easy to differentiate. How about an x? Du equals dx, and then dv is the rest of it, which is g double prime. And so the antiderivative is going to be g prime. Uv minus the integral of v du. So this is going to equal uv, which is x times g prime of x, evaluated at the endpoints, minus the integral of v du, which is g prime of x dx. And that's from 1 to 9. So I've got 9 g prime of 9 minus 1 g prime of 1 minus g evaluated from 1 to 9. So 9 g prime of 9 is 3 minus 1 g prime of 1, 2, minus bracket g of 9, negative 1, minus g of 1, 3. And notice how me using parentheses makes me, I have no difficulty with lots of negatives, and I was able to finish this with 3 minutes to go. And now what I want to do is not look at my answers, but just because if I were you in this test and I actually had 3 minutes left, and you might be that person who works fast, you've got to now at this point check your work. And I think if the way I'm modeling makes it easy to check your work, because if you are transcribing your question down, oftentimes one of the most common errors is transcribing the question down incorrectly. So what I'm going to do is go through my questions, make sure I wrote everything down right to begin with. So what I'm looking for in BC1 is to find the graph that has horizontal tangent lines. Okay, that's when f prime is 0. So horizontal tangent lines when f prime is 0, and f prime is 0 at 3, negative, 1, 6, comma. See, I wrote 68. I think that may have made a difference. I needed a comma there. Okay, so I said neither at the endpoints because I don't know the behavior outside the bounds, and those are endpoints. I think maybe if you said can't have relative extrema at endpoints, that might be just fine too. I don't know. I think because of the definition of relative extrema is that you have to have an open interval around that point, and we don't know the behavior outside it. So I'm basically saying that, like, either you need an open interval or you need to know more information. Okay, same thing. I think I'm good there. Number 2, find the minimum value of f. Minimum, that's a y value. When you talk about the value of a function, you're talking about the outputs. And so you're talking about absolute minimum, and those can happen at the endpoints or critical points. Good thing we already found them from part 1. So we have our endpoints and critical points, and our original function And the trick here is knowing that we know an initial condition. We know f of 1 is -2 from the given information. And so if you utilize the area under the curve and the evaluation theorem from the fundamental theorem of calculus, this whole problem is not that bad. Just keep track of the order that you do things. So I did -1 to 3 for the first one because -1 is to the left of 1. But the rest of them I did for from 1 to that number because that number was to the right of 1. And area under the curve is the signed area under the curve. So this area from 1 to 6 was a -14. I think we're okay on 2. Number 3, did I write it down right? That's probably the most important thing for all of these. I think I did. Okay, and so it's low D high chain rule minus high D low power rule. Square the bottom. Yes, 3 squared is 9. Okay, I can check my simplification. And then I'm plugging in 6. So it's 3 times 6 is 18. E to the g of 6 is 0. E to the 0 is 1. You can leave it as e to the 0. G prime of 6 is 1, and you're multiplying. Good. Subtract e to the 0 times 3. Okay. BC3, good. BC4. Velocity. Integral of velocity is speed. Sorry, integral of speed is distance traveled. Total distance traveled. Net displacement would be the 10 minus 14 there, plus 6. And my 15 minutes is up, and we used it all up, and I hope this is helpful. Come to my office hours on Monday. I noticed that there are more mock exams being thrown out every day. There's a mock exam number 2, part B from the YouTubes. Check those out. I'll look at them soon too. Until then, take care. Have a good weekend. Strive for 5.